Hello, let's solve a JEE question. If sin power 4 alpha plus 4 cos power 4 beta plus 2 is 4 root 2 sin alpha cos beta, where alpha beta belongs to 0 to pi, then cos alpha plus beta minus cos of alpha minus beta. Fine. Now, let's solve this problem in two methods. Uh, in the first method 1, right? In the method 1, let's go for this. This is sin power 4 alpha plus 4 cos power 4 beta plus 2 minus 4 root 2 sin alpha cos beta is equal to 0. Alright. Now, uh, instead of writing sin alpha every time, let's take sin alpha equal to S and cos beta equal to C. Right. Now it will be easier to write S power 4 plus 4 C power 4 plus 2 minus 4 root 2 SC equal to 0. Fine. Now you can see these first two terms. Let's try to write in the form of a plus b whole square. Right? This can be written as a square whole square plus 2c square whole square, which is 4c power 4. Then you can write minus 2 into s square into 2c square. Right? So you are adding this extra term 2s square into 2c square. So you need to compensate with the same term, which is 4 s square c square, and the remaining terms are plus 2 minus 4 root 2 sc equal to 0. Now this term is s square minus 2 c square whole square, right? And the other term is these three terms. Let's try to write these terms even in the form of a plus b whole square. So let's take 4 as common, then this will be a square c square, right? Then this 2 becomes 1 by 2. As you can see, 4 into 1 by 2 is 2 minus root 2 sc is equal to 0. Fine. Now just write it down. S square minus 2c square whole square plus 4 into, now sc square can be written as sc whole square, right? Then this 1 by 2 can be written as 1 by root 2 whole square, and the 2 into sc into 1 by root 2. As you can see, 2 by root 2 is root 2 sc, right? Which is equal to 0. Then this whole term is s square minus 2c square whole square plus 4 into sc minus 1 by root 2 whole square is 0. Now as you can see, these are two square terms, right? S square minus 2c square and sc minus 1 by root 2 whole square, which are their positive numbers, right? Adding the two positive numbers cannot be 0. So each of the term must be 0. Fine. Now this can be s square minus 2c square equal to 0 and sc is equal to 1 by root 2. Fine. Then s square equal to which is 2c square. Fine. Here sc is 1 by root 2. Fine. These are the two conditions, and we need to evaluate the values of alpha and beta. Fine. Now this, if you square this here, this will becomes s square c square equal to 1 by 2. Fine. As you can see here, s square equal to 2c square, or s square into c square can be written as s square by 2. S square by 2 is equal to 1 by 2. Right? 2 2 will get cancelled and you are left with s power 4 equal to 1. S is sine, right? Sine power 4 alpha is equal to 1. Right? Instead of writing sine alpha every time, we have make it as s. Fine. Now, as it's given, alpha beta belongs to in the range of 0 and pi. In 0 and pi, there is only one chance, which becomes 1 for sine case, which is alpha is pi by 2. Right? Then the other is 3 pi by 2, which is out of our given interval, right? 0 to pi. Fine. Now alpha is pi by 2. Now, as you can see, this sc is 1 by root 2, right? Sine alpha, which is sine alpha, cos beta is 1 by root 2. If sine alpha is sine pi by 2, which is 1, then this implies cos beta equal to 1 by root 2. Right? If cos beta is 1 by root 2, if beta is in the range of 0 to pi, then because it's a positive term, it must be in the first quadrant, then beta is pi by 4. Fine. Finally, we have found the values alpha equal to pi by 2 and beta is pi by 4. Fine. Then we need to find cos of alpha plus beta minus cos of alpha minus beta. Cos of alpha plus beta minus cos of alpha minus beta. So this will be cos of pi by 2 plus pi by 4 minus of cos of pi by 2 minus pi by 4. Fine. This will be minus sine pi by 4. Fine. Then this is sine pi by 4. Fine. This will be minus 1 by root 2 minus 1 by root 2 minus 2 by root 2, which is equal to minus root 2. Fine. This is the solution. Now you can do it in other form. Let's do it in method 2. Right? Now let's do it in method 2. Here it's given that sine power 4 alpha plus 4 cos power 4 beta plus 2 is 4 root 2 sine alpha cos beta. Right, here we use the property arithmetic progression always greater than or equal to geometric progression. Fine. Now you can see there is a 4 here, and as you can see root 2 sine alpha sine beta can be made into some form, but there is a 4 factor extra, but here are only 3 terms. So let's write it here. Sine power 4 alpha plus 4 cos power 4 beta, 2 can be written as 1 plus 1, so that it will become 4 terms. Let's bring these 4 on the left hand side, then this becomes by 4 equal to root 2 sine alpha cos beta. Right? Now, as you can see, this is in the form of a plus b plus c plus d by 4 equal to a b c d whole power 1 by 4. As you can see here, if you want to check, let's do a b c d is right sine power 4 alpha 4 into cos power 4 beta into 1 into 1 whole power 1 by 4. Fine. Then this is sine power 4 alpha cos power 4 beta, it will become 4 1 by 4 will get cancelled. Then this is sine alpha cos beta. Fine. This becomes sine power 4 alpha cos power 4 beta. Then this is 1 into 1 will be 1. Then 2 square whole power. Then this is 2 square whole power 1 by 4. This becomes 2. Right. This becomes 2 square whole power 1 by 4. This will becomes root 2 sine alpha cos beta. Fine, which is our case. Fine, then this is true, right? Then this left hand side part is arithmetic progression, then this right hand side part is geometric progression. That means they are both equal, right? Now you can know when arithmetic progression and geometric progression are equal, then the terms must be equal, right? Just you can prove it if there are n numbers a comma b comma c and belongs to up to n terms, its arithmetic progression is a plus b plus c and so on plus up to n by n terms. Then geometric progression is a b c and so on up to n whole power 1 by n. This will be always greater than or equal to is the condition, right? Now if all these terms are equal, that means a equal to b equal to c and so on n, then this will become a plus a up to n. This becomes na by n. Then this becomes a power a into a up into n times will become a power n whole power 1 by n. N will get cancelled and n will get cancelled. Then a equal to a. So arithmetic progression, arithmetic mean becomes geometric mean when the terms must be equal. Fine. In that case, these are the four terms, right? Sine power, our four terms are sine power 4 alpha, 4 cos power 4 beta, 1 and 1. You can write it once. Then these terms must be equal. Fine. Now our given range for alpha beta belongs to 0 comma pi. Fine. It's the same case, right? Now if you equate sine power 4 alpha equal to 1 as the integration, sorry, alpha beta range is 0 to pi, there is only one chance alpha must be pi by 2. Right? Then this is the same, cos power 4 beta equal to 1 by 4. Then cos beta equal to 1 by 2 square into whole power 1 by 4, which is 2. Then beta is pi by 4, right? It's 1 by root 2, right? It's the same thing now, right? Pi by 2 and pi by 4, which we have got it as here pi by 2 and pi by 4, as you can see here. Then it's the same thing. If you substitute there in cos of alpha plus beta minus of cos of alpha minus beta is equal to, sorry, it's getting slow, minus root 2. So this is the solution.